Diamonds. These are real. You probably don't believe me. I wouldn't believe me, but these are real. And so is this. Let's go. This video is sponsored by PCBWay. Unlike the jar of forbidden popping candy on the left here, you really don't want to eat that. The diamond in the nozzle you see is what's known as polycrystalline. These diamonds are made in extreme conditions in a super secret 1 million psi and 1400 degrees Celsius, both at the same time, diamond press that Champion X, the people behind DiamondBack, used to make these nozzles with a solid polycrystalline tip. The process of making the actual tip isn't just about pressure and heat over time though. I mean, it also needs a catalyst of cobalt that you have to somehow remove afterwards, but I'm not even talking about that. That just makes a slug of polycrystalline diamond. Not entirely, as I understand it, unlike this disc that they've sent me. So you also have to cut that to the shape of a nozzle. Have you tried cutting diamond? Exactly. If you're like me, you probably won't be listening at this point because you'll be too busy wondering what polycrystalline actually means. Wikipedia to the rescue, although it's still a bit wordy for my liking. You could read this whole paragraph and still not really know. I think the best TLDR that I can kind of do, it's probably an oversimplification, but feel free to read this page in your own time and see whether you could do better. It's kind of like crystalline structures within crystalline structures that don't align into a massive crystalline array. And the opposite of polycrystalline, or the other type of diamond, is monocrystalline, which are the ones that you kind of are used to seeing. The benefit of a polycrystalline diamond is that if you smack it in any direction, you have virtually no chance, in theory, of being able to fracture it along a plane, because you don't have those kinds of structures anymore. As I understand it, you can still damage a polycrystalline diamond, otherwise how would they cut them or shape them? But it doesn't fracture in the same way anymore, and that makes it less vulnerable to breaking in any meaningful way in use. So you've got the hardest material in the universe that we know of, and you've just made it harder and also less prone to fracture. So that seems like the kind of properties that you would want to use for drilling technology, which is one of the things that Champion X actually manufacture. So they thought at some point, why not use that for 3D printing nozzles, right? I agree. I hope I got all that right. I will point you to Zach Friedman's video from I think it's about a year ago now. It's in the description if you want to see more information about the manufacturing process, because he actually went there and filmed it and did a very comprehensive video on the process. So the reason I have these nozzles, and the reason you all asked me to contact DiamondBack to get them to send me them in the first place, and thank you DiamondBack for doing that and sending these over and making this video possible. The reason was to stick a camera in them and have a look inside. So let's do that before I go into some tests and go into what benefits a diamond in a nozzle might have. Before we get too close, which is honestly easily done with the equipment I have these days, I might be a bit obsessed. The outside of the nozzle has, apart from a serial number, a DiamondBack logo imprinted on the actual diamond. This is kind of small, so you can hardly see it with the naked eye. Here's a banana for scale. Okay, an apple. I don't have any bananas. You have no idea how difficult it is to get bananas. I don't know why. On the opposing side of the actual diamond, and thankfully more readable, is the nozzle size. In this case, it's 1mm, which is the largest size that you can get the DiamondBack in for a V6. If you can't read that, then it's also written on the brass part, so it's probably to help them during assembly more than anything else. Going inside the nozzle, we can see two main things. Well, before that, there's not much to see. In a brass or steel nozzle, you would see bits of cutting compound or swarf or cutting marks, just kind of gross things that are left over from the process of making that nozzle. But obviously, as you can see, there really isn't any of that here. So this nozzle is already much cleaner and manufactured to a much higher standard than I think any that I've seen up to this point. But the two other things that I can see here are the joint between the brass and the diamond, and the internal texture of the diamond. For some reason, I didn't expect the internal texture to be the same as the external. And this is kind of interesting because the flat surface of the tip is polished smooth, but the rest of the surface is kind of textured, and I want to point out that neither of these observations will have much effect mechanically on the extrusion process, at least in my opinion, and I have consulted people who have more qualified opinions than me. Very, very unlikely, because the extrusion process already expects friction at the walls. I talked about that in a previous video, but I wonder if this points to a key part of the manufacturing process, because this kind of texture doesn't look cut, it maybe has been kind of blasted. The final observation, I know that's actually 3 not 2, or possibly 4, but it's how uniform the hole in the tip is. When you get close up to things, especially when you start breaking out the microscope objectives, they usually start to look a bit gnarly because you're getting really close, but DiamondBack nozzles just keep on looking the same smooth round shape, but they just keep getting bigger, which is impressive, but I guess it's a bit boring to look at. I guess it depends what you wanted to see. These purple lumps are, well, I'll give you 3 seconds to guess what they are. They're ice. Why? Because I want to demonstrate another property of diamond. It's incredibly thermally conductive, so I've raided the freezer to bring you a pretty classical demonstration on why diamond is so much better than any other material when it comes to conducting heat. The thing that really stands out to me that you can't experience through the medium of video is how cold this feels when I stick the diamond disc into the ice. I think it's pretty accurate to say it just feels like you're sticking your finger in the ice itself. And that's kind of pretty much the case, and you can see that on the FLIR image. You can see that my finger is kind of pretty much as cold as the ice where it's been touching the disc of diamond. Of course, all these materials that DiamondBack have given me to demonstrate this, they are all very conductive themselves, so they're all quite capable of transferring heat into the ice from your hand. They would make pretty terrible materials to make nozzles out of if they didn't conduct even remotely like that, which is why we don't have glass nozzles. Glass nozzles would be really cool though. But diamond is just so far ahead of the game that it's pretty weird to experience firsthand. I guess most of us go our entire lives without really messing with things that are more conductive than metal, so I suppose we're just not used to it. When it comes to how this increased conductivity helps the print though, that was a can of worms. All I can say is that can is staying closed until a future video, unless you're a Patreon member where you can actually read all about the struggle of the can of worms, why it's staying closed until a future video. But what I will say is 2 things. Firstly, that I put both of these V6 DiamondBack nozzles on the FL Sun S1, because of course that's what I was going to do. And secondly, well, the 1.0mm nozzle achieved 74 cubic millimeters per second. 74. I could probably nudge it a bit higher, but honestly, after 2 days of testing, I was running low on the Sunlu high flow filament that I've been using to test this machine with. And not only is that filament really good for this application, I also wanted to retain consistency between tests, so kind of had to wrap that one up. So anyway, there you go. Bamboo users in the comments, the same people who were commenting on the S1 review. There's the gauntlet, 74 cubic millimeters per second. I'll wait. The 0.4 DiamondBack nozzle was somewhat more modest in max flow rate, and I will say that if you're thinking of improving flow rate, from my tests at least, you will get a lot more benefit from increasing nozzle size generally than you do from changing the technology of the nozzle. So that in and of itself isn't a huge reason to buy a DiamondBack nozzle, at least as far as I could replicate, but I will go into all these findings and what that means in the future episode that I'm still not making right now. So I was thinking about a segue to this video's sponsor, and I realised that there's no such thing as a diamond tip soldering iron. It doesn't sound terribly stupid, does it? You get higher thermal conductivity, you never have to change the tip, it doesn't wear down. Anyway, random thoughts aside, if you have manufacturing or prototyping needs that you can't fulfill in-house, then why not take a look at PCBWay? They can effortlessly take care of your PCB manufacturing needs, as the name suggests, and they can also assemble PCBs like this one, where they put the components on for you, which is useful if you're terrible at soldering. Not like me. I was just testing them. I could 100% solder this. First time. PCBWay also offer CNC services, sheet metal fabrication, even injection moulding if things get serious and you want a lot of parts made. I've worked personally with PCBWay, obviously, and they are there to assist you not just when inquiring about their services, but also I've needed assistance during the fabrication process, and it really helps to have someone looking over what's being manufactured, especially if you're not an engineer and you have zero experience and you don't know whether you're doing things right the first time you do them. So why not give them a look? I've put the links in the description below, along with a new customer discount link, so check that out. Thank you PCBWay for sponsoring this video, and let's get back to the hard topic. Yes, that was a diamond pun. So a more tangible benefit, but still not the actual main benefit of using a diamond tip nozzle, specifically these ones, the DiamondBack ones, because I can't speak for any others that may or may not exist in the future. This is a thing that we already spoke about, and that is the uniformity of the tip, especially the hole in the tip. The theory here is pretty solid, and I covered it in the last episode, actually, where I, for want of a better word, mauled a series of brass nozzles to show that the shape of the tip and the neatness of the tip has a very meaningful effect on the top surface of the extrude. This is going to be a long video if I'm talking about extrude again. The simple fact is that if the tip of your nozzle is neat, then your print will be neat, and because of the next point, the DiamondBack nozzle will stay neat, potentially for the entire life of the printer. Which brings me to the actual main reason why these nozzles exist. Diamond is the hardest material known to mankind, and I already said it's been made to resist fracturing, so this is essentially a forever nozzle, and that's supported by science to such an extent that I don't really need to prove it to you. I mean, what would I do? I try to break a diamond nozzle. I'm not going to be able to. I could probably damage the mount, the brass of the nozzle, but what point would that be? That's not going to happen in normal printing. If you're by some chance a soft diamonder and you somehow don't believe me and you demand proof of this, then fine, DiamondBack have sent me this video. Is this real time? I think it might be, and yeah, that's kind of, yeah. So this feeds into the point before, which was the point that I made last nozzle video. I know I'm making less and less sense as this video goes on. I have a theory that nozzle quality decreases over the life of the nozzle due to the hole in the nozzle gradually becoming oversized compared to what you've got in the slicer settings. That is to say, the longer you use a 0.4 nozzle, the more it becomes like a 0.6 nozzle. We know, or at least I know because I haven't released the video yet where I talked about it, it got delayed, but we know that you can print wider than the nozzle size. We've done that, and we know that that works. But if you go even slightly below the nozzle size, even just a tiny bit below the nozzle size, you start to see quality degradation in weird and specific ways. That's not great when you consider that your average brass nozzle is constantly widening as it ages. It may start as 0.4, but it's not going to stay as exactly 0.4 for very long. Or indeed, it might not be the right size all along, which we also saw in the previous video. And of course, even though I'm not generally a huge user of abrasive filaments at the moment, glass-filled TPU notwithstanding, the supposed benefit of a DiamondBack nozzle is that you can pretty much use it forever and not really substantially wear it. Unless I guess you're printing diamond-filled ABS. Is that a thing? Can that be a thing? I'd buy it. And so I think that brings us to the end of our DiamondBack journey. Do I think it's worth it to buy DiamondBack nozzles? I think to answer that, you need to really have some idea of how many hours you plan to print. If you run a print farm where time is money, then I'd say absolutely yes. It would be a really good investment. If you have a long-term workhorse printer that takes standard nozzle sizes or a tendency to print a lot of abrasive filament, I'd say also absolutely. If you print PLA once in a while though, just kind of, as a hobby, it's probably going to be a harder sell for you. There's no downside to having a diamond nozzle, as far as I'm aware, and it will fractionally improve the quality of your prints, but you might not notice. So there's no reason not to, other than, obviously, the cost. Anyway, that's it. All the links from stuff I've talked about will be in the description. Remember to like and subscribe, and I will see you next time. Thank you for watching.